Okay, now we're just going to be discussing the morphology of the eye, or the anatomy of the eye, with a particular focus on the fibrous layer, or the fibrous tunic, which is our outermost layer of the eye. So the eye is divided into a outermost fibrous layer, or fibrous tunic, and the fibrous layer is composed of the sclera and the cornea. The sclera, which is the white opaque part which makes the posterior 5/6 of the eyeball, and the cornea, which is the transparent part which makes the anterior 1/6 of the eyeball. And then of course you have the vascular layer, more inner, and that's composed of the choroid, which extends into the ciliary body, and of course the iris as well, which is over here. The iris is kind of what gives the colour to the eye and controls the pupil diameter and contracts and relaxes to control the pupil diameter. The ciliary body contains the ciliary muscle as well as the ciliary processes. The process has secretory function because it secretes the aqueous humour, and the muscle of course has functions in contracting and relaxing, and so the muscle kind of holds the ligaments as well that attach to the lens, and then it allows the lens to change the shape of the lens. Now we also have the choroid, which is over here. The choroid is just there to provide nourishment and to kind of absorb the lights that would have otherwise scattered or dispersed. You need to know that fovea centralis retinae is the best vision. That's where you get the best vision because only cones can be found here. But we'll come back to that later on when we start to discuss the retina or vision. First, the way you remember that because this video is going to focus on the fibrous layer or the cornea and the sclera, I want you to remember first, when you see a house, you first see a white window. And the sclera is the white part of the eyeball. It's the 5/6 part of the eyeball, which is quite opaque. Whereas the window, or the cornea, is the anterior 1/6 part of the eyeball, and it's transparent. And I remember transparent and T for transmission. So the fact that it's transparent allows transmission of light into the eye. The cornea forms the anterior part. It's transparent, allows light transmission. Also, the cornea, as you can see, is a curved structure, and that allows for light to be refracted, and light refraction is a property of the cornea. And I think around 80% of light refraction in the eye is due to the cornea. It is well innervated, so it does not have a blood supply. It's avascular, no blood supply, but it has lots of nerve endings and nociceptors for pain receptors, and that's what allows any irritation in the eyeball in the front of the cornea to be detected. The sclera, the posterior 5/6 opaque part, is posterior opaque, is there for protection support, but it's also an attachment site for the extrinsic ocular muscles. Here you can see the lateral rectus, here you can see the medial rectus. Here, in front of the, here's your cornea. Behind the cornea, but in front of your lens, would be your anterior chamber. Sorry, behind the cornea, but in front of your iris, would be your anterior chamber. Behind the iris and between the cornea and the iris would be your posterior chamber. So cornea, iris, posterior chamber, kip, and then lens, iris, posterior chamber, lip, and cornea, iris, anterior chamber, CIA. The sclera has three main layers. The outermost is lamina episcleralis, or the episcleral tissue. But right before you get to the episcleral tissue, the eyeball, or the sclera, actually falls into something called the tenon capsule. Here is your tenon capsule. Your tenon capsule is made up of elastic fibrous connective tissue, and it's what encloses or envelopes the sclera. It forms a protective covering, and it also forms the site of attachment of extraocular muscles. The tenon capsule fuses with the optic nerve sheath posteriorly and anteriorly with the intramuscular septum. The extraocular muscles pierce the tenon capsule. So most externally, actually, you have a tenon capsule. But then as you go more and more in, you have firstly the episcleral tissue of the sclera, then you have the sclera proper, then you have lamina fusca, which is also known as lamina suprachoroidea because it's the connection between the sclera, which is here, and the choroid. So remember, there was the episcleral tissue, then there was the sclera proper, or substantia, was it sclera proper? Yeah. Then you had lamina fusca, the other name for it is lamina fusca, or lamina suprachoroidea. Lamina suprachoroidea makes sense because this is the choroid. The outer layer of the fibrous sclera contains of a dense fibrous connective tissue. So here would be your sclera. Sclera is the white of the eye, but sclera anteriorly kind of continuous with the transparent substantia proper. It's kind of continuous with the cornea. Here's your sclera, here's your cornea. Here's your sclera, here's your cornea. Now, the cornea, by the way, is formed by non-keratinized stratified squamous epithelium. Non-keratinized stratified squamous epithelium. You have the insertion of the 4 recti muscles. By the way, we have the proper substance of the sclera, which contains collagen fibers. And then the innermost layer was lamina suprachoroidea, which contains woody fibers that connect lamina and sclera to the choroid. We also have an equator, and we're going to identify the thinnest and thickest parts of the sclera. And retinaculum trabeculae. Retinaculum trabeculae is the area between the sclera and the iris. RT between the SI. Sclera and the iris. So that would be your retinaculum trabeculae. So the 4 extraocular muscles. The extraocular muscles include the superior rectus, medial rectus, lateral rectus, inferior rectus, and of course inferior oblique. And these pierce the tenon capsule, and they pierce the sclera in front of the equator. In front of the equator. The line, so if this was the equator halfway along the eyeball, these extraocular muscles pierce it in front, this way. The line connecting the insertion of the rectine series is known as spiral line of Tillot. Now, if this was your sclera and here is your attachment of muscles, here would be your equator. Now, the sclera is actually thinnest right where the attachment of the extraocular muscles occurs, or right in front of the equator. So if this would be your equator, here would be your extraocular muscle attachment site, and that's where the sclera would be the thinnest. And then the sclera would thicken posteriorly. And that's why it's 1 millimeter here, but near the front it's almost 0.3 millimeters. Then, of course, between the sclera and the cornea, by the way, is the scleral-corneal junction, the sclerocorneal junction, or it's also known as limbus. Muscles of the eyeball. Now, I got this from another YouTube video, which you can definitely check out because it's quite useful mnemonics. Now, the extrinsic muscles can be defined by slim rectangular object, and slim rectangular object reminds me of superior, lateral, inferior, and medial. Superior rectus, lateral rectus, inferior rectus, and medial rectus. Rectangular is supposed to remind you of rectus, and objects oblique at superior and inferior. Now we have intrinsic muscles. These include, if you remember, Sweetie is drawing Cinderella. Remember sphincter pupillae of the iris, sphincter pupillae of the iris, dilator pupillae of the iris, and ciliary muscles. Sweetie, sphincter pupillae, drawing, dilator pupillae, and Cinderella, ciliary muscles. So here's your anterior chamber, and here's your posterior. Here's your anterior chamber, and here's your posterior chamber. In between your anterior and posterior chamber, you have, of course, the iris, and you have the lens posteriorly. Attached to the lens are the suspensory ligament of the lens, which then, of course, attached to the ciliary body. The choroid is what continues into the ciliary body, and then the iris, continues into the ciliary body, but the iris is part of the uveal tract. Here's your sclera, here's your cornea, here's your scleral corneal junction, or limbus, here's your canal of Schlemm, which is located in the scleral corneal junction, or the limbus. Canal of Schlemm is responsible for draining your aqueous humor. Your aqueous humor is produced over here by the ciliary processes of the ciliary body. Your suspensory ligaments of the lens are interrelated to changing the shape of the lens to be able to have visual accommodation. Then you have your vitreous humor located here, and posteriorly you have the cornea, the sclera. 2/3 of the sclera will continue to merge with the dura mater that ensheaths the optic nerve, but around 1/3 or less than that would cross over here. Now, here there's something called lamina cribrosa. Lamina cribrosa is a little bit of a little space here which has perforations, and those perforations are for the fasciculi, nerve bundles of the optic nerve, as well as for the central retinal artery and vein. Here's your macula, and here's your fovea. We'll come to that later when we look at the retina. We were talking about lamina cribrosa, right? So here would be your lamina cribrosa, kind of where the optic nerve merges and starts to form. The lamina cribrosa has holes for, and then excuse the swear word, oh crap. O is supposed to remind you of optic nerve, fasciculi, and central retinal artery and veins. Those also transmit through the lamina cribrosa, through this place. Okay, lamina cribrosa bulges out when there's intraocular pressure rise. Let's talk about the canal of Schlemm. So we said the ciliary processes were the ones that secreted the aqueous humor, and they secreted it over here into the posterior chamber, which was in lip, lens, iris, posterior chamber. And then anteriorly we had CIA. So that was the anterior chamber. Between the cornea and iris was the anterior chamber. Here you can see it. Now your canal of Schlemm is located in the limbus, which was, I just told you about, scleral corneal junction. In the limbus is the canal of Schlemm. So it's secreted by ciliary process, but it goes through this way and it exits via the canal of Schlemm. There's an angle you need to know. Firstly, you have the iridocorneal angle. The iridocorneal angle would be here, between your iris and the cornea. That's your iridocorneal angle. And you can say that the Schlemm's canal is formed at the iridocorneal angle. Iridocorneal angle. And you also have just a corneal angle, I believe, which would be here. But here's what's important, is the iridocorneal angle. How does the aqueous humor circulate? So it's formed by the ciliary processes, goes through the posterior chamber, and it's drained by the canal of Schlemm at the iridocorneal angle, which then gets drained furthermore. Now, the aqueous humor is active, so it's constantly changing and constantly being refreshed and resupplied. Here, fluid forms here at the ciliary processes, and it exits here at the canal of Schlemm, or Koch. Layers of the cornea are, remember the burger analogy, so you're eating a burger, and the burger has a top bun, and then it has a slice of cheese, then it had the patty, then it had the salad, and then it had the lower bun. And remember, ABCDE. A is for anterior or epithelium. Epithelium. So the cornea has an epithelium, and it has a Bowman's capsule, Bowman's membrane, not a Bowman's capsule, Bowman's membrane. By the way, the epithelium is stratified, squamous, non-keratinized. Then the Bowman's membrane contains loads and loads and loads of cells, I think. 5 to 6 cell layers over here. Then you have a corneal stroma, and that's the one that contains our lamellae. Our corneal stroma contains our lamellae, which allow for the transparency of the cornea. These allow for the transparency of the cornea. Then we have our Descemet's membrane, ABCD Descemet's membrane. And then we have our endothelium. Our endothelium is helpful in relative dehydration of this area, which allows the cornea to remain hydrated. Another thing, the cornea, remember, did not have any blood supply. So the way that it got nutritive, the way that it was provided the nutrition was by this aqueous humor, which has dissolved substances which then provide the nutrients for the cornea. Here's it again. You have your epithelium, you have your basement's membrane with multiple cell layers, you have your corneal stroma, you have your Descemet's membrane, and you have your endothelium. The stroma I mentioned had lamellae. The lamellae, they are essentially collagen bundles, and they're 200 to 300 bundles, 500 bundles peripherally, and a lot of them are arranged at 90-degree angles. Lamellae are arranged regularly, almost right angle to each other, and it has around 200 layers of lamellae, and they ensure transparency by these lamellar arrangement. Okay.